When you're solving a system of equations like this, you are looking for the variables, the xy pair or point, that make both equations true. So as we're looking at this guy, it turns out that both of these are lines. I've got y to the first degree and x to the first degree, which makes these really, really easy to solve with graphs. There are three different kinds of solutions that you can get when you're graphing systems that have two lines in them. The first one is if your two lines happen to cross. If they cross, that means you've got a point or an xy pair in common that make both of those equations true, one solution. If instead those lines happen to be parallel, that means that there are no solutions, but you can have those lines instead be right on top of one another, meaning they're exactly the same line, so they share every single point, giving you infinitely many solutions. Let's go ahead and solve this first one and find out which case we've got. Now, as I'm going through this, I want to give you some really, really easy steps to follow. If you're solving by graphing, the first thing that you want to do is to get both equations in slope-intercept form, y equals mx plus b, and I've got that. So I'm ready for my second step, and that's to graph both of these lines. Now, for the first line, I need my slope. So for that first line, my slope is equal to 2, but I'm going to think of that as a 2 over 1. And my y-intercept is that number on the end that's going to be a -1. So I can go ahead and plot this by starting at that -1. And then I'm going to move up 2 and over 1 to get to the second point. Let's go ahead and connect those dots into a line, and it looks like this. Now I'm ready to graph that second line. I again need a slope, and I notice in front of the x is a negative sign. I can think of that as a -1 or a -1 over 1. My y-intercept, that b value, is the 2 on the end. So I want to start at 2, and then I'm going to go down 1 over 1 to find my next point. I can actually see where these two cross because it was one of my points. And I've got this. I can go back and find that intersection point, which is this guy right here. And it happens to be 1 for x and 1 for y. So we can express our answer as the point 1, 1. Or we can say x is equal to 1 and y is equal to 1. We could even check that by plugging them back into our equations, both of them, and making sure that it's true. Here comes our next set of equations. So as I'm working on these, I want both of them to be in slope-intercept form. And the first one is, so I've got y is equal to x plus 2. That one's ready to graph, but I need to work on that second one. As I'm working on that second one, I really want y by itself. So I'm going to subtract the x to move it to the other side. So minus x. I have negative y is equal to, I'm going to write the x first, negative x plus 3, and now let's divide both sides by a -1, -1, and -1. I get y is equal to negative over negative is going to be positive x minus 3. So now I've got my two equations to graph. I've got this one and this one. Let's go ahead and start with the one in red. For that one in red, I notice that I've got a slope of 1 if I put 1 there in front, and I've got an intercept, a y-intercept there of 2. So I'm going to go ahead and plot 2 first on the y-axis, and my slope is 1, which you can think of as 1 over 1. So I'm going to go up 1 over 1, and that's going to find me a second point. Let's go ahead and graph that line, and my line looks like this. Okay, here comes the second one, our blue line. So for our blue line, my slope again is 1, which I can think of as 1 over 1, just like the last one. And my intercept, that b value, is -3. So this time I'm going to start with an intercept of -3 on the y-axis. I need to again go up 1 and over 1 to find a second point. Let's go ahead and graph that line. My line looks like this. These two lines are parallel. Because these two lines are parallel, they are never going to cross, which means they don't have any x, y in common. So we can say that there is no solution No x and y pair that make both of my equations true. Here comes our next one. Now, again, our first step is to get both of these into slope-intercept form. So let's go ahead and do that with that first one. I've got 2y is equal to negative 4x plus 6. It's almost there. I just need to divide everybody by a 2. So divide by 2, divide by 2, divide by 2. Y is equal to, just doing the math, negative 4 over 2 is negative 2x. 6 over 2 is equal to 3. Now for this one, I've got both my slope, so m is equal to negative 2, and my y-intercept, b is equal to 3. So there's my first equation in slope-intercept form. Let's do the same with the second equation. The second equation actually takes a little less work because see that y is already just a y. I just need to subtract the 2x from both sides. Minus 2x minus 2x. This is going to give me y on one side. So y is equal to, I'm going to write that x term first. Do you see what is coming? I end up with exactly the same equation, and it's helpful to put it in slope-intercept form, exactly the same equation that I had before. Now, I could graph this, so I've got 3, 1, 2, 3, and then a slope of negative 2, so down 2 over 1. So my graph for both of these looks like this. And if I were to graph the other one, I mean, it's not very exciting, right? It's going to be exactly the same. Now, the trick, there are infinitely many solutions. Every single point on these two lines match. And remember that our solution are intersection points. So in order to express the solution, I don't just want any points. I want all of the points on this line. So to express that solution, I'm going to say, let me move this up out of the way a little bit. It is the set of all points. Remember, not just any points, but all points. And this little line means such that it makes this equation true. And it doesn't matter which equation you pick because they're the same. Such that y is equal to negative 2x plus 3. That's my condition. So it means all of the points on this same line. You guys are doing so great. In our next video, I want to show you a much easier way to solve these with some algebra and elimination method. Thanks so much for watching.